I would like to classify hazards into three parts. They are ra, va, var. That means read after write, write after write, write after read. So far whatever the hazards you have studied, they are actually read after write hazards. Let's recall. So when you have instruction add R1, R2, R3, here R1 is getting modified, right? Then if you have another instruction add something R4 and R5 and R1, you see here you are reading R1, right? But generally if in the pipeline what happens is, if you don't have forwarding technique or whatever, then you will be reading this R1 before this writing, correct? But what is the correct thing? We should read this one after this write. We should read R1 here after write. That's why this is called read after write hazard. Okay, so we have already studied that. Now we'll see two more hazards. One is write after write hazard, second one write after read hazard. Whatever the pipeline model we are following, where we have write back stage in the last, because of that you never get write after write hazard and write after read hazard. In some pipelines, like in different pipelines, you might get write after write hazard, write after read hazard. I will show with one example. For that I am taking a different pipeline than what we were discussing. Okay, so let us start with write after write hazard. So the idea about write after write is that hazard says that we have to write after another write. Okay, so why it should happen we will see. Example, let's say you have a load instruction followed by add instruction, but I am not following the regular pipeline and we are having a different stages, like I mean not regular one, it is a pipeline with different stages. You see here you have a pipeline with instruction fetch, instruction decode, execute, memory 1, memory 2, write back. There are two memory cycles or memory stages. Now in the same pipeline you have instruction fetch, instruction decode, execute, write back. So this kind of model is a, I can say, in that we have variable number of stages, correct? Here you have 3 plus 3, 6 stages, here 4 stages. In this kind of pipelines only you get write after write hazard. We will see, we try to just understand what is write after write. Okay, that is enough. So example, if I am loading the word R1 into R1, 0 of R2, that means we have to go to memory location R2, right? And we have to store that into R1, correct? So where are you reading that register R1 and where are you writing this R1? We will be writing that R1 in the last stage. This is write back stage. Okay, assume that in memory 1 and memory 2 you are reading the data which has to be read, okay, which has to be written. Now see this one, why there are only 4 stages for this add instruction is, it is simply, I mean there is no memory access, right? When there is no memory access, then that stage is completely cancelled. Such a pipeline you have. Okay, I can say that it is a variable length stage pipeline. Now in that you will be fetching the instruction, you will be decoding it, and you are adding here R1, R2 and R3. We are storing the result back. If you see carefully, you are actually updating R1 here and updating R1 here, but you are updating R1 here. Let me write R1 star. But according to our programming logic, when you have these kind of two instructions, this first of all load word should update R1. That means because of this instruction R1 should be updated first, then because of this R1 should be updated next, correct? I can say that this should be first, this should be second, correct? But what is going to happen in this one is, here R1 is modified in 1, 2, 3, 4, 5, 6, 6th clock cycle. In this instruction, which is add instruction, R1 is modified in the write back stage, which is at 5th clock cycle. Then this will be updated first. That means this instruction is updating for R1 first, then first instruction is updating R1 later. Then you get wrong answer. So that's why. So I want to say here, this is wrong. This is a hazard, and that hazard is, what is the reason it is hazard? Because we have to write after this write. We have to write this write after this write. That's why this is a hazard, and the classification is write after write. Now similarly we will see write after read. So write after read hazard says that we have to write after some read. Okay, now we will see example. Let's say you have store word and add instructions. With that I am going to explain write after read. Again, here you have variable length stages, like various variable number of stages. Fetch, decode, execute. You have again two memory stages and write back. And instruction fetch, instruction decode, here execution, write back. Because add instruction requires only 4 stages. Maybe this is another implementation people used to implement. Don't worry, because I did not discuss this kind of pipelines, right? There in the life or in the real life, there can be various kind of models, right? So we can't study everything, because now we would like to discuss about this kind of hazards. For that, I am just showing you the different kinds of pipelines with different stages. Okay, just try to understand that this kind of stages also exist. Fetch, decode, because you are accessing the memory, that's why there are two extra stages, memory 1, memory 2. Now let us see how these two instructions are getting executed here. So here, since it is a store word, what happens is we will be accessing the memory, correct? First of all, we will be going to 0 of R2. That means, so R2, let us say 100, then 100 plus 0, 100. We will be going to memory address 100, and we are storing the content of R1, right? So R1's content is, let's say, 50. So you can imagine like this. This is your main memory. In the main memory, we will be going to memory address 100, where we will be writing 50. So where it happens, where really we are storing, in which stage we will be storing this 50 in the memory address is here. See, memory 2, right? Remember it. Now second one, we have add instruction. Add instruction is adding R3 and R4, and it is storing the result in R2. That we will be doing in write back. Okay. So if you carefully observe, this R2 is important for us, correct? So what is R2's content initially? 100, correct? Now assume that, let's say, rather than generally we access registers here in the decode stage, correct? So you are not accessing register here, let's say. You want to go to memory location 100, for that you need a register R2, but you are reading register R2 value in the memory stage, especially in the second half. That is assumption. Then only I can explain you right after read hazard in this example. What are you doing now? Finally, we are reading register R2 here. Don't think why we are reading here. Such a way it is planned. Okay. They don't know about right after read hazard. That's why they did it. So if you are reading here, but in the first half, let's say you are writing in the write back stage, then what is going to happen? In that circumstances, R2 is written here first, then later that will be read, correct? But since this is the first instruction, we should read R2 first. Really, if we had read R2 here, there is no problem, right? But now it's a problem. If you read here in the memory stage, okay, so of course that's a weird thing why they are doing, but maybe because of the adjustment of clock cycles, everything, maybe instruction decode is taking a lot of time. To save the time, to make all the stages equal, maybe in the memory stage too they are reading the registers, okay, whatever the reason. So in that case you get right after read hazard, correct? We should read here, see, we should write here after this read, but what we are doing in this model, we are writing before this read. That is wrong. That's why that hazard is called right after read hazard. What is your suggestion here? To make these things correct, this second instruction should write after read. That's it. So these are the various different classifications of hazards. Already we know that Ra is one famous hazard, because in our regular examples you get Ra hazard, but for WAW hazard and VAR hazard we need different kind of pipelines or different kind of models, right? Finally you remember this thing, only Ra hazards are possible in our models, okay?